Think it's time? Okay, welcome everyone. I hope you're here for the serverless talk, not because you wanted to find a nice comfy place after lunch. Anyway, in both cases, I'll try to make the best of it. So welcome to my talk. It's about it's about serverless and why I think it's the future of the cloud. It's actually my first time here in Vienna at a conference. I've been to Austria many times, mostly for skiing, just a few weeks ago, because you guys have the best mountains, right? But today I don't want to talk about mountains. I want to talk about even something which is even higher, which is the cloud, right? It's also very beautiful, and there's lots of interesting things happening, and one of it is serverless. So before we go into the content, let me do a quick introduction of myself. My name is Bert Ertman. I'm from the Netherlands. I'm the Director of Technology Outreach at a company called Luminous. There's about 150, 160 of us. We are mostly based in the Netherlands, but we also have offices in the UK and the US. We do some interesting projects for our customers, and we develop our own technology and products that we try to use in our projects. So my background has mostly been around Java. I was fortunate enough to be using the first APIs that hit the internet all the way back in 1995. I think it was about 3 weeks old when I did an internship, and I chose to do it with Java. I built some applets for the educational, in the educational space. They're actually still around. Nobody's able to use them because you can't run applets anymore, but they're still out there on the internet. All right, and I've been speaking at many other conferences since. So let's talk about the star of today, which is not me, but which is serverless. So I thought, well, let's start it off by showing you this picture. And I call it the evolution of compute, or actually the evolution of virtualization, if you wish. So if you look at your left-hand side, you see physical computers. And if you think about it, it was not that long ago, maybe 8 to 10 years ago, that when we started developing our applications, we were in the end eventually deploying them on real physical servers, right? Maybe 8 years, 10 years ago, that was actually a pretty common use case. And those applications were installed on a server which was either under your desk or in a data center somewhere, right? And then, let's say 6 to 8 years ago, we massively started into virtualization techniques. First off, buying bigger servers where we can run multiple virtual servers on top of one physical server, and then eventually these techniques got far more advanced, and we had whole data centers running virtual computers. And then we moved those data centers, well, to the other end of the internet maybe, to some cloud provider maybe, who was doing virtualization techniques for us. And then maybe a few years ago, we rediscovered virtualization in a different way with the rise of the container technologies like Docker, for example. But now there's this new kid on the block, which is also maybe a rediscovery of virtualization. It's called serverless, or it's known by different names, which I will touch upon in a minute. And serverless is now at the pinnacle of this virtualization cycle. And I will explain to you why. So first off, why do we need a new paradigm for computing these days? Because we have so many others. Well, the thing is that if you think about the picture that I just shown you, that we like to think of running our applications on top of servers. So the whole concept of a server is very important to us for some reason, right? And it's so important that you can compare it to pets, for example, right? So if you have a dog or a cat, right, then we take care of our servers as if they were a pet, right? So you give it a name, you give it some food every now and then, you take great care of it, and most of the times you are really upset when they go belly up, right? So it's the same with servers. Now, instead of thinking about this old-fashioned idea of knowing all the details and caring about servers, with today's technology, we should think more about them as cattle, like the cows you see in the picture, for example, because we are not really interested in the individual animal, but we are interested in what they produce. So in the case of cows, that could be milk or meat, depending on your background and religion. But anyway, we're interested in their produce and not in the individual animal. In fact, if one of the individual animals starts to underperform, we can just take it out, replace it with something else, right? And then we can still be happy. So the produce of a server is actually compute cycles, right? So instead of thinking about the stuff that we put our application on as an individual animal, we should think about it as a group of things producing compute for us. And we want to use little bit of compute every now and then in order to run our applications. The other thing why serverless is interesting is if you go back to the original promise of the cloud, then it was supposed to be about pay as you go, right? So we were supposed to be only paying for what we were actually using, which seems like a fair model. But if you think about the cloud for a while and you think about virtual servers, right, then you are paying for that server whether you do anything useful with it or not. And you are even paying for that server whether you are using it or not. So if you're not using it and it's sitting there idle, you still pay for it. And even if you shut it down, but you keep the image around in the cloud, you most of the time still pay for that server, right? And it's not even doing anything useful for you. So instead of being pay as you go, the cloud was about pay as you go and also as you don't go, which is an acronym I made up, right? I think it's pretty strong, but haven't seen much acceptance for it yet. So serverless is interesting. It all took off, I think, a few years ago when Werner Vogels, who is the CTO of Amazon, coined this quote at one of Amazon's conferences where he said, "No server is easier to manage than no server at all," which is absolutely true, of course. So if we can eliminate taking care of servers from our programming model and our deployment models, that could be interesting. So let's talk about the name for a little while. So serverless is actually a funny name because it, well, mostly describes what it's not, right? We often see that naming in IT trends. Think about NoSQL, right? It's a bunch of databases, completely different databases, who have nothing in common except for the fact that they don't have a structured query language. So then we call it NoSQL. So with serverless, the same thing. So there's a bunch of different implementations, have a few things in common, and well, there are still servers involved. That may be a spoiler alert for you, but there's probably still servers, but you won't see them in the programming model, right? And I don't even think there will be less servers involved. I think there will be even more servers involved. But so it's a funny name. It's also known by different names. So if somebody talks to you about FaaS or functions as a service, it's mostly about the same thing, or actually FaaS can be considered a subset of serverless, but we'll get back to it later in the presentation. And if you read industry analyst reports, for example, written by Gartner, they talk about serverless as function PaaS. So they think it's like a new way of doing a platform as a service, but then purely based on functions. And then there's other people that like to refer to this trend as backend as a service, which I find a really funny name. Don't know about you, but if I come home tonight and my wife asks me, "Did you have an interesting day?" And I say, "Well, yeah, I heard a really interesting talk about backends as a service," I think she gets a really funny idea about what I'm doing, right? Although this works great at birthday parties. So when someone comes up to you and say, "Well, what do you do?" And then instead of that awkward answer like "I fix other people's computers," you can now say, "Well, I'm in backend as a service," and they probably avoid you for the rest of the party, right? So that's cool. All right. So more seriously though, serverless is serious stuff because it has its own manifesto, right? So if you take yourself seriously these days, you gotta have your own manifesto, and so does serverless. So here we go. There's a bunch of interesting points in there. First off, it's about functions. So instead of writing applications, we are now breaking everything down into smaller pieces, into functions, and they are both the unit of deployment and also the unit of scaling, which means that you write a function, you zip it up or whatever, and that is immediately your unit of deployment. So we're uploading functions into a function PaaS or a cloud provider, and that is the way of deployment. It's also the way of scaling, meaning that when a request comes in for your function, then the cloud provider will just run an instance of that function. So for every request that comes in, it will run an instance of your function. In the programming model, you won't see any machines, whether physical or virtual or containers or whatever, right? So it's just about the functions. So it's top level stuff. There's nothing there's nothing visible about the infrastructure on which it runs, right? That should be taken care of by the actual cloud provider. The function is inherently stateless, meaning that you can stuff in some state when you kick off the function, then do something interesting with that state, manipulate it, and then when your function is done, it returns a result. And if that result is interesting enough to be saved somewhere, then you have to take care of it yourself. So there's no storage functionality part of this platform. However, there are still things like databases around. So part of your function code can be to insert that intermediately answer or that result into a database. Function scale per request, and this is actually pretty cool because you now can no longer over or under provision your functionality. So imagine you build a web shop, right? Then there's this few times per year where you have to deal with peak loads. For example, during Christmas shopping time or whatever. And so most of the time when you run web shops, you run over provisioned, right? Because there's like a lot of servers doing nothing but waiting for that one peak load per year that you should be able to handle, because otherwise it will take your site down. Now with serverless, there will be nothing running for you if nobody is using your function. But as soon as people start to use your function, then the cloud provider will automatically start to provision more compute resources for your functions. So you are always provisioned in relation to the amount of load which is set on your functions. This is actually cool stuff, because given the fact that you don't pay for stuff that you don't use, this means that you now have automatic scaling, right? And this also goes the other way. So you can now never under provision, you can also never over provision, so you never pay for stuff that you don't use. You also never pay for idle. So if I create the greatest function, put it out there in the cloud, and nobody will ever use it, I never pay for that function. But instead, if I go to a PaaS provider and I deploy my PaaS application on their platform, I do have to pay for stuff, even if I don't use it, right? It's implicitly fault tolerant. Actually, this is the problem of the cloud provider once again. So if something in my function goes wrong because the underlying infrastructure has problems for whatever reason, then the next incoming request will just be run on a different piece of hardware or virtualized hardware, whatever, right? So that's up to the cloud provider to handle. Because we scale per function instance, right? You do not have to think about fault tolerance because it will be handled for you automatically. It's all about bringing your own code. This actually means pick a language of your choice. If the cloud provider supports it, that's fine. If he doesn't, he probably has a way of for you to bring your own runtime. And basically you package per function images and you upload those into the cloud, set a trigger, and that's how you run stuff. And then finally, it is stated that metrics and logging are a universal right. And this means that your cloud provider must have a way to collect metrics about people running your functions, so you know what's actually going on. And there will be some centralized logging going on. So instead of chasing down servers to figure out the error logs or whatever, the cloud provider is handling this for you in a centralized place. So you can just go somewhere where all the logs of all your function instances are without you need to worry about individual servers or obtaining logs from individual servers. So this yields a bunch of benefits. First off, we no longer have to think about servers anymore. So we don't have to apply patches to operating systems or put extra memory into servers or whatever. We only pay for stuff that we actually use, and we don't pay for stuff that we don't use. And there's automatic scaling, both in the provisioning way and also in the fault tolerance way, which is actually cool stuff. So when you come from a Java background, this also means that you are no longer having to deal with application servers anymore, because you're not dealing with applications, but with smaller items, functions in this case. And in terms of virtualization, we are also no longer dealing with containers. So it's sad for the little whale there, right? But we are no longer caring about Docker, because this is just one level of abstraction higher. So far, seems like cats riding unicorns, right? Almost too good to be true. So let's take a closer look. There's a bunch of serverless implementations out there. So I already showed you the quote by Werner Vogels, and Amazon was the first company actually to offer a solution for this. So it was announced back in November 2014, AWS Lambda. It's actually the first serverless implementation. And then, as you can see, the big four cloud providers now all offer something similar. They vary a little bit in terms of the runtimes that they support, but the programming model is basically the same for all of them, and they all more or less adhere to the manifesto that I've just shown you. For the remainder of this talk, I will use some examples and demos with AWS Lambda, because, well, in my opinion, they're still the front runner in this space. They have the most features right now. The others are rapidly catching up, so that might change in a year from now or whatever. But they're still the front runner, and it's really easy to get started. You just need a credit card to sign up. They won't charge you for anything. You get like 1 million instances for free every month. So you have to do really crazy stuff in order to actually get a bill. But it's really easy to get up and running, as I will show you in a minute. So Amazon offers support for a number of languages. So over the past few years, they had like 4 runtimes: Python, Node.js or JavaScript, C# and Java 8. And they recently, about 2 months ago, they also announced Go support. So if you're more like a DevOps guy, then you might like Go. So as you can see, there's only one real language in this list, and which is the language I will use for the demos, of course. So let's start and write our first Lambda then. So for this, I'm switching to Eclipse. I use Eclipse because they have a really nice toolkit with plugins for Eclipse. If you prefer IntelliJ or some other IDE, then there's some other plugins for that, but it's not as elaborate as the toolkit that they have for Eclipse. So let's start with a simple new Lambda Java project. Let's call it Voxxed Vienna. And then I will generate a standard Lambda, and I will take a custom object as an input, just a simple Java object. Won't do anything fancy here. So just generate some skeleton code for this. And then, well, let's do a quick hello world implementation, right? That's how we start all projects in Java. So we get some object as input. Let's say it's a string of some kind, right? And we just echo back hello with the input. Now I can save this. Then one of the things that the plugin does is it generates a unit test for me as well. So I can, well, it's basically a function, so that's easy to unit test, right? So I can just set my input. Right, and then I can just quickly check whether I meet that input. And then just run this as a regular unit test. And we have a green bar. Okay, well, nothing spectacular here so far. Now let's run this, let's not run the test, but let's run the real function in the cloud. So we use the plugin for this. So we say, well, run this function on AWS Lambda. It says, well, in order to do that, I need to upload it first. So it just takes my Java code, creates a zip file out of it, and then uploads it into AWS. So upload. Now I have to do a couple of configuration choices here. First off, I need to find my region. So I'm running most of my stuff in the Ireland data center, EU West 1, because it has most of the Amazon functionality. And then we can say, well, it's my first Lambda function. Do next, so we give it a meaningful description here. Then I need to configure some security role. I won't bother you with this, but I have just some predefined security role here, which has access to the logs and is able to execute some Lambda functionality. And then I have to pick a so-called S3 bucket. Now S3 is their object storage, and one of the buckets in that object store contains all the zip file with the Lambda functions. So that's basically the bucket I'm selecting here. So that's where I will upload it. And then there's some memory setting I have to do here. So it asks me, how much memory does your function need? Now basically we're not thinking about this as a server, right? But I can configure this memory in order to tune the JVM. So if I think it needs more memory, I can up it a little bit. If I think it needs less memory, I do less, because the amount of memory that you use and the runtime are actually the two parameters that your bill will be calculated on. So in this case, it's just hello world. So let's go with 256. That will be more than enough. Although it's Java, right? So you never know. And then let's give it a timeout of 2 seconds, right? Probably needs way, way less, but it's probably fine. So let's press finish. It will now create a zip file. Depending on the speed of the wireless, it will take a little bit because it packages some runtime libraries with it, so a few megabytes big. Then it will upload it into S3. There it goes. And then it's ready and waiting for some input. So now we can try it again and say, run this function on AWS Lambda. And I can give it some input. This, and then invoke it. There we go. Right. So we get some basic output. So this goes to the cloud, comes back as hello Voxxed Vienna, and then we get some basic metrics. So we get some start ID, some request ID, and then some basic metrics in terms of this is the total duration. You see that this will be rounded up to the next 100 milliseconds. That's the amount of time I will get billed for, and then there's its 256 megabytes of memory, of which I only used 43, and 43 for Hello World seems reasonable, right? So now if I run it again, I've already warmed up the JVM now, so you will see better response times. So if I run it again, right, you see it's now going even faster. If I run it again, it will probably be just a few milliseconds, right? But that's about it. But well, it doesn't matter if it's really faster because we pay for 100 milliseconds anyway. Okay. So if I switch to the cloud, then this is the Lambda dashboard when you log into your Amazon console. I can go to my functions overview. If I refresh it and I see the latest one, we see that there's my first Lambda function, which I just created with the meaningful description here. I can open it up. And here it is with its basic configuration of the timeout and the max memory. And I can go to the monitoring tab over here, and I can see the amount of invocations, etc., etc. And I can also jump to the centralized logging file, where it will show the exact same logging as it did in the Eclipse output, right? So basically, this is how you write your first Lambda. Okay, let's go back to slides for a few seconds.
How long will this stay warm? This function?
How long will this what?
Will it stay warm, like until it
Okay.
goes back to 100 milliseconds?
Yeah. So the question is, how long will the function stay warm or stay hot in terms of Amazon, right? So staying hot means that there now is some compute resource or some virtual computer with a JVM configured on it where my function is actually running and waiting for incoming requests. So it will stay hot for about an hour, 45 minutes to an hour, which I know from experience. But you cannot really calculate on that, right? Because Amazon might change that when they change the underlying runtime. So you see that people use like a box of tricks in order to make sure their Java functions stay hot by just calling into their own function, say every 10 minutes or so, or every half an hour. So you make sure that your function stays hot and you don't pay the penalty of actually building up the JVM. Depending on your use case, this could be a problem for you if it takes too long for the function from a cold start. On the other hand, there's a lot of use cases where these extra 100 milliseconds don't really make much of a difference, right? But it really depends on your use case. All right. So lambdas and serverless functions in general are said to be event-driven, which means that there will occur some event which will then invoke our function with the data from that event as input. Now at AWS there's a whole bunch of event sources. So I don't know if you're familiar with AWS. If you are, then you probably know what all of these funny names mean. If you are not familiar with them, I'll try to translate it for you. And so there's many event sources to pick from. For example, you can front your lambdas with maybe a REST API, so you can map incoming HTTP requests directly to your Lambda. I will show you that later on. You can also map your Lambdas to CRUD events happening on one of Amazon's data sources. So for example, if somebody inserts a file into S3, or if somebody changes a record in the database, that might then trigger your Lambda function to do something useful with that event. You could also use all sorts of incoming messages, like email messages. Somebody emails to a certain mailbox, that might trigger a Lambda, which will then do automatic processing of that message. Or you can use one of the message queuing services that Amazon has, and you just insert a message in the queue, and that will trigger Lambdas. Or you can do like real-time log or stream processing. So for example, you can hook up your Lambda via Amazon Kinesis to the Twitter firehose, and you can do some sentiment analysis, right? So you just filter tweets from the Twitter firehose, and then if something interesting happens, if you see an interesting tweet, you process that tweet using a Lambda function. And you can hook it up to many more Amazon internal configuration sources. So you can also use it to orchestrate all of the Amazon services. So if somebody spins up a virtual server, for example, that may trigger a Lambda that does some housekeeping for that server or notifies somebody or whatever, right? Now let's take a step back and think how we can put this technology to use, right? So let's think a bit about how we traditionally create web applications, for example, and see if we can recreate those applications using this kind of technology. So if I think about a traditional web application, I see this three-tiered thing where we have some sort of client, could be the browser, could be an app nowadays running on your phone or tablet, and then we have some web application running server-side, either serving static content or doing actually dynamic stuff, or maybe even generating HTML depending on your framework. And then there's probably some backend database that keeps track of state. Now let's see if we can recreate applications like this, but then in a completely serverless fashion. So the answer is yes, we can, but the diagram looks a little bit more elaborate. So let me walk you through it. So first off, we need to find a way in order to get static data in the browser. Now, if you create an application yourself and you want to get static data in the browser, you need to set up a web server and serve some static content. Now, in this case, I could use a CDN, a content delivery network, or in the case of Amazon, I could even use an S3 bucket to place a bunch of static HTML and CSS and JavaScript files in there, and then serve that out as a static website. So you can think of S3 or the CDN as a serverless service. You don't administer the service running underneath, and you can use it to serve out your static content. Or you can deploy your application, your app, your phone app or your tablet app in an app store somewhere, and you use that as a distribution mechanism. So the client is able to either download that app or download the static files from the CDN or from S3 directly. The next step that we should do is we should find something that can handle authentication for us, right? Instead of writing it ourselves or running it on the backend, we can now also integrate with some third-party service, for example, maybe OAuth or something similar. And using this third-party service, we now also have a serverless version of our authentication. The next step is to expose some dynamic data into our static content, right? So we have a browser that needs some data. So if I build a shopping site, I need to have a catalog of products somewhere. So most cloud providers offer databases that can expose the content of that database directly to the web, maybe by fronting it with a REST API or using some other trick. But if you have a table with product information and you just expose that read-only, right, then it's perfectly sensible to do it like this. So the databases from a cloud provider can also be thought of as serverless, because you don't care about scaling that database to specific servers and managing those servers, right? So if you just put a bunch of catalog data into a cloud database and then expose it via REST services to your client running maybe Angular or some similar web development framework, that will be a perfect way of exposing data to the client. The next step would be to handle some of the old-fashioned session flow, right? So if the client is using its application to go from page to page, to navigate around, then there's a bit of controller logic involved to guide him across the pages and to run certain logic. And maybe in the old days you used to program that kind of logic on the server with JSF, for example, or some other stateful website framework, right? But nowadays with frameworks like Angular or something similar, they all have this model view controller capabilities which can run on the client. So in this case, we use that kind of technology as well. Then finally, we need to call to the backend to do something interesting for us. Maybe run some more advanced logic or run some logic that we don't want to expose to the client directly. Now in this case, we need to front that with an API as well. So a service like an API gateway comes into play, where on the left-hand side we can expose like a REST API, simple get, put, post, delete operations. And then on the right-hand side, we can hook it up to, for example, a Lambda function. So let's have a Lambda function that does some advanced search capabilities which can't be handled on the client for some stupid reason, right? So it may use the same input data, the same catalog database, but then it performs its function on the server and it's being fronted with an API via the API gateway. And we can do the same for the purchase function. So that seems like functionality you want to keep on the server for several reasons. Maybe because you're checking credit card data or whatever, or you're storing credit card data there. So you have this purchase function that has an end result, which is probably an order, which you then store into the purchase database, right? And now using an architecture like this, you can see that you can now build web applications entirely serverless, right? So how is this an accomplishment? Well, the thing is, you no longer care about running and maintaining servers. You no longer care about running and maintaining web servers. You no longer care about running and maintaining application servers. You can now do it all in a serverless fashion. Although you can do it, might not be the right reason to actually do that, right? So don't go back to work tomorrow or the day after and convert all of your traditional web applications into serverless applications just yet. Could be fun, but it's not exactly what the technology is for, right? If you only have a hammer, everything looks like a nail is what they say, and you should not fall into that trap with serverless. So let's think of a few reasons where serverless is actually a really good fit. So one of them is event-based processing. So let's say we have a scenario like this, where we have an application, once again could be a web application, could also be a mobile app, right? And that application uploads something to a database. So let's say we're a startup company and we are launching a new service. And for the user to be able to use the server, he needs to sign up and needs to fill out a profile. And then part of that profile is creating a profile picture, right? So the user takes a phone, creates a picture of himself or herself, and then uploads that picture into an S3 bucket, right? So there's like a 2-3 megabyte photo being uploaded in there. And then we have a Lambda function listening to that bucket. And so whenever somebody inserts a picture in there, it will take the incoming picture, convert it into a thumbnail of say 100 by 100 pixels, and then stores that thumbnail in another bucket, which is the bucket which will be used for all the profile pictures. And then it can just get rid of the incoming picture because it's a lot of data which you will never use again. For a number of reasons, this is an interesting scenario, because if you are the startup building and launching this, then your startup is about performing that super cool service. Your startup is not about handling profile data, right? And if your application or your service gets picked up and you become really, really popular overnight, then there will be hundreds or thousands or millions of signups for your application. And this may immediately trash all your servers in a more traditional model, because now you have to have a lot of servers being able to deal with the peak load of people creating profiles for your service, right? Instead of people using your service. That's the next step. But in a lot of cases, this is where startups fail because they are not able to scale up with the amount of users, right? So using this kind of technology where you can never under or over provision, right? This may immediately offer you a bunch of benefits. So I've created something similar here. So let's go to the browser and let's go to the S3 management console. So this is an overview of my S3 service. So I have a bunch of buckets in there, and one of the buckets is called incoming files for Lambda. So it's currently empty, right? So it's empty. And then there's another bucket in there which says processed image thumbnails, which is also currently empty. And then I have a Lambda function, which is called S3 event handler. And this Lambda function listens to incoming S3 events. So if I click on it, we can see the configuration. And what it does is it listens for events of type object created. So whenever somebody creates a new object in this bucket, in the bucket called incoming files for Lambda, then that event will be the trigger for my Lambda function. It will then take the incoming object, convert it into a thumbnail image, and then place it into the other bucket that I just shown you. So let's try it out. Let's go to the incoming files for Lambda, then upload an image. So let's go to my desktop here. So I have a nice image over here. It's about 2000 by 2000 pixels, right? So open it and then upload it into the bucket. Right, now let's wait for a little bit. And it's the cloud, right? So it's eventually consistent. So maybe it needs a little help every now and then. So you see it's gone now. So that's a good sign actually. So then we go to the other bucket, the processed image thumbnails. And then again, it's eventually consistent. So if you help it a little bit, you see there's a thumbnail now. And I can open it up and we see that it now has created a 100 by 100 pixel image file, right? So here you see it in action. So creating something like this is actually pretty straightforward. I can show you the code, but it's nothing more than just obtaining the object from the bucket, using a little bit of image IO magic and creating a thumbnail, and then putting it back into another bucket, right? And this is a very useful scenario. In fact, this is actually code that we use in our production applications in order to offload profile creation from the real functionality of the application. Some of you might say, hey, I've seen this before. This is called database triggers. And we all seen where that went, right? Okay, I'm with you on that one. If you put triggers on everything, triggering things which trigger other things, which trigger other things, it will get messy really soon. But then again, applied to the right scenarios or the right use cases, this may be a really interesting case to put serverless to use. But there's other examples. Let's get back to the whole backend as a service thing. Here we see another one. It's heavily used, as you can see. And so in this scenario, we have a typical mobile backend. So in this case, maybe we're a company that is really good at creating very compelling mobile applications using iOS or Android or whatever, right? Or maybe it's web applications, that's fine too. And then for some reason, we need some backend functionality. So if you have to do that without using a technique called serverless, you probably go to Google App Engine or you go to Heroku or something similar, and then you set up a web server or an application server or something similar. And you need to figure out how to do it and how to configure it, and you have to take care of it, and then you run some backend modules on there actually performing the functionality. Now in this case, using serverless technology, I can create a Lambda function that does something interesting, offers some business logic, and then I simply front it with a REST API using the Amazon API gateway, and maybe I put some database in the back where I can store results, and this is how I make the business functionality of my Lambda function available to the web, and how I can integrate with my mobile app, for example. And since the API gateway is able of fronting it with REST interfaces, it integrates really well with popular web frameworks as well. So let's take a look at a different demo scenario here. So in this case, yeah, unfortunately it's in Dutch, right? But Dutch and German are a little bit similar, right? So you're probably able to follow along, but I'll translate for you. So this is a killer app. So I'm a developer, probably like most of you. So I get a company car. And the cool thing about company cars is you're really happy with it for the first couple of weeks. And then after a couple of weeks you think, when am I get to choose my next company car, right? Does that sound familiar? A little bit, right? So this application, let's say I have a new company car. Well, I actually do have a new company car. I got it about a month ago. So I say the start of my contract was somewhere in February. Then the runtime of my contract is 4 years, right? I have to run it for 4 years unless I hit a maximum number of kilometers. So if I hit 4 years first, I have to return it. But if I hit 140k kilometers, I can return the car as well. That's how lease contracts usually work. In this case, petrol cars are 140k. So currently it's at 2,000 kilometers, right? So I want to know, do I have to sit out the entire 4 years, or do I get to choose my car, let's say, after 2.5 years or after 3 years, right? So that's basically what this Lambda function does. So this is my cool web application or my cool iOS app or whatever. I can then run a check, and if all goes well, you also see my user interface skills are really top-notch, right? So it gives me some basic information. So you have a 4-year contract. You're about 2% into your contract right now. The average amount of kilometers that you need to drive is at least 95 per day. Right now I'm only doing 76, right? So no way in hell I will get a new car within 4 years, right? So instead of flying here, I probably should have driven to Vienna, right? That will make me get a new car any sooner. Now, apart from the stupid example, right? This is a very basic static website thingy. So if I go to S3 again, just some static files, some HTML, CSS, a little bit of jQuery, right? So I have a bucket here for this app, which just contain all of these static sources, and I've marked it as hosting a static website. And now I'm just serving those files to the browser from my S3 bucket. So I don't need a web server, right? That's what I mentioned in the earlier example. And then on the back end, there's this function for it. Here it is. And so this function has an API gateway configured to it. So if I click on it, we can see that it has some post method assigned to it. So I can even click on that, and then we come into the configuration of the API gateway. And you can see that my API currently consists of just a post request. That post request comes in, and then I wire that incoming request to my Lambda function on the right-hand side over here, and then we route the answer back to the incoming request. And this supports staging and versioning and throttling and all kind of cool stuff, which is part of the API gateway. And this is something that almost comes for free out of the box, right? So it's really easy to do this. If you have an existing REST contract in the form of, say, a Swagger definition or a Swagger contract, you can just upload that contract and it will create that API for you, and then you can wire the individual methods to backend Lambda functions, right? Which is a pretty cool use case. So how much time do we have left? Okay. All right, so that's another useful scenario. Then there's a bunch of other interesting use cases. So I know a lot of clients and examples of companies and people that actually run Lambda functions as some sort of glue in between other Amazon services, or maybe not just Amazon, you can also do it with Google or with Microsoft's cloud implementations, right? So as soon as something happens, for example, in terms of CI/CD stuff, so if you commit some source code into a repository, then you just trigger your own build pipeline using this kind of technology. You can just create an entire build pipeline with Lambda functions calling into other services. That's how you orchestrate your DTAP environments or your CI/CD pipeline. Then cloud providers nowadays are experimenting a lot with this technology, like bots, language interpretation, and voice control. And these are also really cool use cases. So I have another example here where we say, well, let's not use a mouse or a keyboard as input for our service, but let's use voice as input, right? So in this case, Amazon has this Echo device. I just brought one over here. This is the old-fashioned Echo. You see a smaller one on the picture over there, which is the Echo Dot, and they have a couple of others as well. So this is a device which can interpret a command. Then it will, when I wake it up, it will send my command to Amazon, which will translate my voice command into something that an application or a thing which I can control using the device can work with. And this way, I can then will either trigger some other device in my house, or I can use the Alexa Skills Kit to trigger a Lambda function, which I have written. Right? So I can hook it up to my own Lambda functions. That's actually pretty cool. So I wrote a very simple Lambda function that does like a hello world message. And then using the Alexa Skills Development Kit, I then hook it up to the device over here. And then I can just issue it a command. And then hopefully if the internet works, and it's currently tethering through my phone, so I hope it works. So let's try it out. Let's turn the volume up a little bit. Alexa, ask Demo to say hi.
Hello everyone at Voxxed Vienna. I hope you are doing okay and that you like Bert's serverless talk. Have a great day.
Okay, so this is just a very simple hello world thingy, but imagine what you can do when you can hook this up to other devices in your house, right? So to your Philips light bulbs, or to whatever other devices that you have, or just hook it up into your enterprise software, right? So instead of just using the keyboard and the mouse as input, you can now just start talking to the device and then have it perform stuff like do a build or whatever, or spin up a new server from me, right? I mean, it's really easy to do using the Alexa Skills Kit. All right, well, so far for Hello World demos. Let's turn it up a notch. There's a really well-documented use case about some heavy usage of technology like Lambda. So in this case, it's about Expedia. Probably you all know the company Expedia, right? It's like a search machine for flights and hotel and car rentals. And you just type in the name of a hotel or the name of a city, and then all kind of magic is happening behind the scenes. So Expedia has a very well-documented case where they say, well, we used to run our own data centers, and we had lots and lots of computers in there doing, well, the functionality behind these search bars. And also for internal automation, where they ran their own CI/CD implementation, right? Now, they have replaced a lot of that using Lambda technology. And as you can tell from the numbers, and these numbers are already a little dated, so probably even more insane right now, but they have replaced like half of their data center by running computations with Lambda. So they run about 2.5 billion computations every month, and that's a lot. It comes down to more than 200K computer hours, so that's a lot of servers, right? And if you look at the number at the bottom, that's the most staggering one, because that's the bill that they get from Amazon, right? So they have replaced half a data center with about $550 bill each month, right? Now, this may be a very specific use case, and they might get some interesting discounts from Amazon, right? But if you think about this for a while, right, then why would you pay for servers and manage servers that you are almost never using or are almost idle all the time, right? If you think of interesting use cases, in your case, where you can leverage this kind of technology, then you can get insane cost savings, right? Well, because of using this, right? So it's definitely interesting to think about. Now, of course, I only showed you all the positive things, right? So there's downsides to this model too. So let's talk about that for a little bit. First off, there's lots of vendor control, right? All the stuff I've been showing you is all AWS based. If you go to Microsoft or IBM or Google, you will find similar implementations, but in practice they all work a little bit differently, right? So writing a Hello World Lambda is still pretty portable, but as soon as you do more useful stuff, you start using the databases from Amazon or the API gateway or the log monitoring or whatever, and that's where the lock-in comes in. Now, of course, this lock-in might be an obstacle to you, or it may also be a choice, because you get lots of cool stuff in return. So there's like this conscious decision that you have to make of the amount of lock-in that you allow yourself to sacrifice for getting all the goodies in return, right? Now, if you think about this serverless thing as becoming full circle in IT, right? Then it's basically having compute as a service, is basically going back to the mainframe days, right? Where we have this big unit of compute, and then my piece of functionality wants a few time slices every now and then to do some calculations. And we can think about the cloud as the same thing. And back in those days, this big machine was either from IBM or some similar company, and then we didn't worry about lock-in either. So maybe this may be a problem for you. For a lot of cases, this isn't such a big problem. It's only a problem in theory, but it is a conscious decision that you have to make. Then there's a bunch of things which is a little bit harder to do with Lambdas. For example, there's no support for multi-tenancy out of the box. So if you run this functionality and you want to have the same function being used by different customers, then you have to solve the multi-tenancy problem yourself. And this means either deploying multiple versions of your Lambda or passing along some customer ID somehow. Or I mean, it's a problem which can be solved, but there's no support out of the box for multi-tenancy with Lambdas or with any of the other cloud provider implementations either. Then some people have security concerns, because if you say, well, I open up my logic as a whole bunch of smaller pieces of invocable functions from the internet, right, then the attack surface just becomes broader. That doesn't mean that everything is open and vulnerable, right? I mean, you can protect it using an API gateway and other security measures, but you have to protect it, right? And that's mostly the problem, right? It's not that you can't protect it, but it's that people don't think about it. And so, for example, my simple car lease thingy that I just showed you has an open API. So if somebody decides to do a denial of service attack on it, I have a really big bill at the end of the month, right? So you should consider those things, and you should take appropriate measures. Then, because we're no longer caring about servers and we lose this notion of servers, you can't run specific server optimizations. So if you have a great algorithm to mine bitcoins, right, it's probably not an interesting implementation to write it as a Lambda function, because you have no clue what is running underneath. Might be a slow server, just a little bit of memory, just one processor maybe. You have no clue, so you can't optimize for it. So if you have any algorithm that you really need to optimize for in terms of hardware usage, etc., then you need to use other measures. You can still use Lambdas in order to kick off those things. So for example, if I would write a Bitcoin mining algorithm, I would run it on Amazon's GPU instances, which are really big machines, also very expensive ones. So I would just use a Lambda to fire up that GPU instance, then run my heavy calculation, and as soon as it's done, I will use another Lambda just to kill that instance so I don't pay for it anymore. Right? So you can use the Lambdas to do a little bit of flow control there, but the heavily optimized stuff goes into something else. Then your execution time is limited. The maximum runtime for a Lambda function right now is 3 minutes. So if you need to run calculations which take more than that, you need to reach into your bag of tricks. So you have Lambdas trying to call themselves, right? So to make iterative functions. I think that's just a hack, right? So if you have something with a long runtime, don't write it as a Lambda, or just chop it up into several subroutines, whatever. But don't go into hacking modes in order to get it to work with a technology which is not suitable for it. Then we already talked a little bit about the startup latency with languages like C# and Java. We have the virtual machine that needs to be fired up, so you take a little hit in terms of startup. There's tricks that you can do in order to keep your instance warm. But then again, if you use other languages like Python or JavaScript, you don't have this problem. So maybe for some functionality, you might want to use one of those runtimes. For other kind of functionality where it doesn't really matter or where you find a way around it, you're fine using a real programming language. Right. Then testing, I already showed you a little bit about it. Functions in general are easy to unit test. So a lot of the testing that you want to do can be done as unit testing. Then again, if I start to use, for example, S3 or other databases and API gateways, etc., then you see that you will be transitioning from unit testing into some form of integration testing. This is still a little bit problematic because it is really hard to replicate the Amazon cloud on your laptop, right? That's pretty hard to do. Although currently they do have a couple of functions as like mockups. So for example, for S3 and for DynamoDB, they have like small little mock-ups that you can run on your laptop. So in that case, you can do some limited integration testing. But then again, the most interesting integration testing can only happen in production. So get used to it. That's what the big ballers do, right? They run every testing in production. The cool thing about this is that, let's say the API gateway supports different stages. So you can have like a dev or an acceptance or a prod stage. Your Lambdas also support multiple versions. So you can apply tags to Lambdas, and then you can divide the load over multiple tags. So for example, you can do A/B testing or something similar with Lambdas. There's some capability for that in the platform, but then there's also some capability still lacking. So it might be a little bit of a struggle to get all the testing right. And then finally, discovery is very limited in terms of Lambdas cannot discover other Lambda functions directly. So there's not like a registry for serverless functions. If one function wants to invoke another one, there has to be like an event thing in between. So if the first one is done, it can fire like a message via SQS or some other eventing service, and that will then trigger another Lambda. So Lambdas cannot call Lambdas directly. Well, that's currently the case. I'm not sure if they're going to change that, but this is how they work. So with that, I think that serverless is rapidly being embraced by all of the major cloud providers. Not only in the public cloud, there's also implementations that offer you on-premise implementation of running your own serverless frameworks. Although in that case, if you run them on-premise, you're also responsible for running your own infrastructure. So in that case, it's no longer serverless, right? If you have to take care of your own infrastructure. But for the programmers, it can still be serverless. So we have to get used as functions as first-class citizens and no longer applications. Functions get triggered by events, right? They're completely stateless and transient. And the platform handles all the scaling for you, which is actually a good thing because therefore it's infinitely scalable. And I think it's giving the cloud a real run for its money, right? This is the true pay-as-you-go model, implemented in a way that you never pay for idle stuff. So you get lots of bang for the buck. That's what the Expedia scenario shows. And yeah, the only real downside is that it's very much proprietary. So that's a very conscious choice that you have to make. So I threw away all of my servers. I think this is the future of the cloud. So get used to it. Thank you. I think we're out of time, so if you have any questions, you can please come up or you can shout.
If I'm uploading a Java function, am I restricted somehow in which libraries I include?
Okay, so the question is, if you create a Java function, are you restricted in terms of which libraries you can use? No, not really. There's not any runtime dependencies provided by Amazon. So every library that you want to use has to be packaged as part of the upload zip file. So if you want to run the Spring framework as part of your Lambda function, you just package it with the function and then you upload it into the cloud. There's not limitations like you have with FaaS, where you have blacklisting and whitelisting of certain classes or packages, right? So you can just package everything that you like. Yeah. But your upload will get bigger, right? Okay. Any other questions? Yeah, some more.
Can I directly call a Lambda function from the front end or from the browser, or do I always need to call it through the API?
Yeah, so the question is, can you directly call a Lambda function? No, you need to expose it somehow. So in this case, you can expose it using an API gateway with a REST API, or you expose it by having some other event thing in front of it. So in this case, could be voice interpretation, or you have a database in front of it, which will then trigger the function with an event. Yeah. More questions? No? Okay, thank you very much. See you around.